right. Good afternoon, everybody, and welcome at Hellebrekers. First of all, I would like to say a warm welcome to our colleagues and partners from Canada. Olga, Heather, very nice to have you here. For me, it's a special day, to be honest. A special day, something we worked towards in the last couple of years. So I'm very proud of what we've achieved, and we will show that to you today. Also, a very warm welcome to the attendees who were willing today to show up and show their interest in the system we jointly created for a European market, the smart imaging system from PPO. But later on, we will tell a lot more about that. Also, a warm welcome to the company Plucon, who really stick their neck out in the last couple of years by implementing that system. And also, I'm not seeing you, but also a very warm welcome to all the attendees which are digital online attending this session. Before we start, I would like to ask you to shut down or shut off your telephone, because I think if it goes off, then it will interfere with the system, and then it will affect the quality of and content of the things we record. Today we have a customer day, first one in a very long time, but also a launch of the smart imaging system of PPO, which is a system which has existed for quite a long time now, especially on the American and North American market. But a couple of years ago, a European customer, Plucon, was interested in their solution, in this solution, and we were connected to each other, and we created the system for the European market. I hope that it's going to be a very interactive session. So if you have any questions for me or for the PPO team or for Team de Weus, who is our mechanical partner in this solution, please feel free to come up with any questions. Interactive means also that after our introductions, we also go to the live live situation where the system is being installed. It's in Ommel, excuse me. It's in Ommel. And we have a live connection with the colleagues from PPO, and they will walk you through the complete system. And we see it in full operation. And also, again, it's the first time we do it like this, an interactive session. So we go through the system, and please, any questions you have during that live session, or you would like to focus on a certain part of the machine, just feel free to shout out. And Jamie, who's there, will stop, and we'll try to bring that in view. Today, I have to click. And I thought today we talk about new technologies. We talk about technologies which are available today in the market, but which are not often used yet, because maybe we don't know the potential, maybe we don't know what the possibilities are. But what we do know is that you sitting here and the people who are online at the moment, we do know that you guys are one of the early adapters. You guys are being confronted with the latest technology in quality detection, in chemical composition of food detection, and we know the conventional ways of food quality inspection. We know the ways like the X-ray. It detects metal. It detects other sort of metal-like materials. We know that the inspection costs a lot of labor. But other foreign materials, they are very hard to detect. And the team of OCA, PPO, in the last couple of years, developed a system where it is possible via vision technology, and Olga will tell a lot more about that later on, but with vision technology and artificial intelligence, we are able, first of all, to detect the other foreign materials, like wood or plastic. It's an inline solution, so it will not block or slow down your production process. But there is so much more possible with that type of technology. Think about the quality of the product. Think of the quality of the chemical composition, which we are able then to make choices in. So this solution is not a physical solution, but it's a solution based on data. And today, we know what we can do with the data, but who knows what the possibilities are in the near future. Time will tell. So again, early adapters. We know that the business you're in is sometimes conventional, with conventional technologies, but this here, what we discussed today, is innovative, and it's based on the latest technologies. Of course, there is a planning today. I'm starting off. Afterwards, Olga is going to tell us all about the system and her beautiful company. Then Bart is here as well, from Pukon. He's sitting over there. And Bart contacted me a couple of years ago, saying, Maurice, we're planning of installing a system. I said, well, Bart, that's very good. That's very nice. I said, but yeah, this time it's a little bit different, because it's coming from Canada, and the system is not based on European regulation. So can you help us out to, jointly with the supplier, PPO at that time, and still, can you help them out to transfer that to a system which is based on European regulation? But another very important part of that transformation was not only transforming the system from European from Canadian standards to European standards, but also service and maintenance is very important. Because of course we can translate something from A to B and make it. But what happens when the system has something or has some issues, which can happen in a production facility? So service is also very important, and that's something we provide as well. And together with PPO, we jointly set up a service and support solution. We continue then to the live stream, which I said, with Jamie. Jamie's there from PPO, and afterwards. And unfortunately, for those who are digitally attending, you don't have a food and drink afterwards, but you have to do that yourself then. All right, but first of all, a little bit about Hellebrekers, and then we continue. Hellebrekers, nowadays we have over 280 experts, based on 7 locations in the Netherlands and Belgium. And from this year we exist 54 years. We've got 2 businesses. Maybe a little bit odd if you look closely at them, but you know, those 2 businesses balance everything very good. First of all, we have a business unit which is working and creating water and leisure solutions. We're mainly in the communal swimming pools. And on the other hand, we got a business unit which is focusing on industrial automation. Now, what type of businesses do we execute then within the water and leisure markets? Now, I will not mention them all, but of course, indoor swimming pools, and also, for example, which is a nice niche market, we install swimming pools also in the super yachts environment. Now, what do we do then exactly? We are responsible for the complete installation of a swimming pool. The water purification installation, the building automation installation. We design it, we engineer it, and we maintain it. And afterwards, we provide a service and maintenance support contract to keep the swimming pool operational. Another very interesting project is a project which is created in Rotterdam. It's called the RIF 010 project. It's a closed canal where we generate waves. And the technology behind creating those waves comes from Hellebrekers. And it's a joint effort of the water and leisure team and the industrial automation department. And maybe you've seen those movies online already. Then we quickly jump over. Oh, there's a nice movie included. There you go. The waves are being created every couple of seconds. And the beautiful part of this natural or unnatural wave is that they can actually practice their technique and improve their technique. Then quickly going over the industrial automation business unit. We're active in the food and non-food industry. We're active at the end clients. We also work closely with overall equipment and manufacturers. And also a very strong position within the concrete industry. So what we do? From the beginning on, when we have a contact with the customer, we, of course, advise. When there is a P&D, for example, we design, we install it, and eventually manage it through service contracts. If you look at the complete package, top-down, we have got a in-house designed management execution software, which focus on the layer between the ERP and the production facility. Of course, the PLC part and the SCADA part is part of our solution, and robotics and augmented reality and machine learning. One of the projects we are actually, and at this moment are executing, is a very big project within, for example, Nestlé. They're building a factory within a factory, and it's an E&I installation, electrical and instrumental installation, and that project involves in total more than 90 kilometers of wiring, of cabling, almost 4 kilometers of cable trays, and in total we've been spending 70,000 hours of work over there. So it's a very big project we've been executing the last year. Another quick insight is a project we did together with the company Weus, where we renewed the automation of handling the beer barrels. It's including robotization, it's including controls within their facility. Another project we executed was for the company FedEx, and they asked us to create a system where we were able to handle parcels recognized by a vision technology. It's a combination of vision and robotics, where we were able to I'd say in the past we got several people taking out the parcels and putting it on the belt, and we now completely fully automated that by a robot in combination with vision. And last, also a robotic solutions is a solution we created for a company who creates parcels of surgical items. for eye operations. Normally, there were a lot of people standing behind the belt, selecting all the instruments, and now through vision technology and in combination with robots, we detect the object and we prepare the packages and customized sets to execute those surgeries for the surgeons who execute those surgeries. And then, of course, our collaboration with P&P Optica, creating and building, not creating, but building the smart imaging system for PPO. And as said, a couple of years ago, we were contacted by Plucon in combination with PPO, and they asked us to transfer the machine towards the European market. It's a system, very advanced, and based on hyperspectral imaging. And I've been really training on that word because it's pretty difficult to say that in general, just to say it. And it's something completely different, based on vision technology, based on AI. It's an inline solution, and it's the possibilities based on quality are tremendous. But as you notice, maybe I am not fully familiar with the whole system and the possibilities. And I would like to introduce Olga to take you along the trip and the trip of P&P of the last couple of years and explain us a lot more about this beautiful system.
Thank you.
Thank you.
Thank you, Maurice. Thanks. Thank you, Maurice, and thank you, everyone here at Hellebrekers, and of course at Plucon for letting us play in Europe a little bit. So I'm going to give you a little bit of a discussion about detection in the meat industry. And hello to everyone here. Thank you for coming, and thank you everyone at the webinar. I hope you will enjoy some of the videos and some of the presentation that we do here. So what we're seeing is, in the meat industry, it always amazes me, the history of the meat industry. It was one of the first automated industries in the world. So actually, Ford in Chicago borrowed the idea from meat processing plants to build his first T model systems. The problem is, as automotive changed and other industries changed, the meat industry, unfortunately, has kind of stayed the same for the last 100 years. What we have to do is enter into the new century where labor issues become critical, where quality of food is becoming more and more critical, where waste has to be minimized. So the industry is in a sore need of new technologies and adopting new methods of working with the product. So one of the biggest problems that we chose to address is finding foreign materials. And right now, to give you an idea, and again, I know a lot of you are from the meat industry, but in general, meat processing plants are factories, and therefore there are many, many opportunities for foreign materials to enter the stream of product, whether it is conveyor belts breaking, gloves falling apart, or wooden pallets falling apart when being used inside of the plant. A lot of these materials currently cannot be found by methodology other than having a lot of human inspectors on the line. And that includes materials like rubbers and plastics, essentially things that are low density, or rule of thumb is anything that floats in water is too low a density to be found by X-rays. And many of these objects are color-wise very similar to the background. So imagine ground meat going into a sausage has a lot of variability, a lot of kind of dark and light shadows. It's very difficult to see something like a piece of cardboard on that material. So even humans are not very good at this. So how do you solve this problem? And our background at PPO was medical imaging and doing hyperspectral imaging, and it also took me a very long time to pronounce it properly. The technology is really how do we look at light slightly differently than what human eyes do or typical cameras. So we want to address these problems in the plant, but nothing really right now existed to allow us to look for foreign materials. How do we solve this? We built a machine, and this is now, luckily for us and Hellebrekers and Plucon, this is our fourth design that was implemented here in Europe. A machine that can go online anywhere in the meat process and measure chemical composition. How do we do this is really using a combination of high-end spectroscopy that can see sufficient amount of information very quickly and a lot of new AI or machine learning models. And, right now we're all overwhelmed by the AI speak. Everybody is using ChatGPT and whatnot. But AI really has been around for about 4 decades in terms of neural networks and kind of simulating more or less how a human brain learns, or I always compare this to a dog's brain. In a airport, for example, when you want to teach a dog to smell out sausages and some sort of drugs, you have to teach the dog. It's the same thing. We have to teach the machine to think and recognize patterns. And that's what really our company does a lot of, is building these models to recognize patterns from how we see light and identify things that are different or unexpected from what we expect. We've right now built about 20 of these machines. The oldest machine is running for over 5 years in plants. And as I said, we kind of managed to do many iterations of these to make them turnkey solution where you put one in a plant. Cleanliness is easy to maintain. It doesn't take very long time to clean it. Maintenance is relatively easy, and I'm sure I'm going to hear from you if it's not, and from Plucon as well. But right now, we really want to have as many drop-in-place, fast replacement parts, and really allow the plant to have a very easy experience, so that even though the technology is complex, the use of the technology is very easy for the plant to support. And what do we find? And here you have pictures of actual finds. My favorite is probably this little thing, because no human, no X-ray, no camera would have ever found a piece of cotton on a piece of fat. So just to give you an idea, because we're using hyperspectral imaging, we do not have to worry about contrast. So white on white, blue on blue, it doesn't matter, because what we're looking for is really a chemical signature of the product. So very small pieces, and I'll show you a little bit later, but in general, we have ability to detect about 97% of all objects as small as 1.5 millimeters. Of course, that depends on the presentation and type of the object, but we see very small things very often. If they're in the stream and we have line of sight of them, to them, we can see them. We also have now several models of the machine built to handle different types of proteins. So we can handle both chicken, and this is what you'll see at Plucon, but we also have worked a lot in the pork and beef industries, where size trims, ground product can be inspected. One of the newer additions to our portfolio is bacon pieces. Bacon is a tremendously fast-growing market in the United States, particularly. The statistics on bacon consumptions are going through the roof, and they were already extremely high. So it's a great market for us. We also have entered the pet food industry, where various types of meats are mixed together for fresh food for pets. And where we typically belong in the plant is both in pre-processing, kind of when we have a secondary processing plant, getting raw material from somewhere, making sure that all the raw material is clean, and we expect that the plant has start clean, stay clean process. And we allow our customers to really tell apart, good suppliers from bad suppliers. And it's sometimes staggering how much difference there is between a clean processor and a dirty processor. So our suppliers are seeing better product coming through to their plant. On the kind of further processing, we also tend to be placed close to packaging, but before packaging, where we have almost end product. So for example, in sausage making, we will look at the ground meat about to be mixed into batches to go into sausage production. So again, we're very open to who we work with, and one of the aspects that's really fascinating to me is how fresh meat differs from meat that has been around for a couple of days. It actually is a lot of variability, so our AI models really have picked up a lot of variabilities and are learning on these products. So every customer that we enable actually provides more information to feed into our models and allows us to become better and better over time. And that's really the advantage of using high-end AI models. It's that flexibility that we get over time to learn. And to give you an idea, I calculated at the beginning of the year that we have seen about 3 Netflix worth of libraries of data, and we have by now monitored several billion pounds of product, even kilograms. I think by now we're in several billion kilograms. So vast amounts of data, vast amount of variability, and many foreign objects that we've seen. We do not care what kind of object we see. If it doesn't look like background or like meat, we flag it, and over time we can even learn what type of object it is. Okay. So what's really the difference here? The difference really is, instead of seeing 3 wavelengths like your eyes do, or 3 wavelengths like your camera does, a standard iPhone will see 3 wavelengths, we actually see about 600 wavelengths in the near-infrared spectrum. So think about the darkest red you can see. We start there, and we go even further into the near-infrared. And that's because water absorption and protein and kind of organic molecules absorb more light in that spectrum. So we're not looking at just visible light, but we're looking at near-infrared light. What it gives us is really unmatched detection, independence of contrast, and really looking at chemical signatures. Okay. Why is this important? So in this kind of being simplistic, no detection system will ever find 100% of what's out there. Just like when we have medical screenings and we want to see, whatever, our cholesterol, it doesn't mean that you will, even if you have low cholesterol, it doesn't mean you will not have a heart attack. Same thing happens in detection. We will never detect everything. There is no system or combination of systems that are foolproof. However, we can expand how much of foreign materials or things that are unwanted we see. And this is it's very mathematical looking, but it's one of the most interesting and key slides in my entire deck. Because the most important thing about a good detection system is not only what it finds, but it's also what it doesn't reject. So a perfect system, a perfect detection system would actually reject 100% of everything. You would never get foreign materials to your customer's site if you rejected everything. The problem is you can't. That's it. And there is orders of magnitude more good things going through a process than bad things. To give you an idea, our typical chicken customer will have maybe 40 or so foreign materials a week when they're processing hundreds of thousands of kilos of product in that same week. So the amount of things we find is tiny compared to what goes through. We have to be exceptionally good at eliminating what's called true positives, false positive, which is detections of things that aren't there. And that's really the biggest mathematical problem that we have to solve. Reject a little and find as many foreign materials as we possibly can. So this is kind of zooming into this a little bit, but essentially imagine we have this vast area of materials that are healthy, very few true foreign materials, but there is that overlap. And detection systems typically tune how much of true product are you willing to reject, and what's the sensitivity or how many foreign materials you can find. So this is the area that mathematics live in for us. Okay. And this shows if you want to find tiny things, you will have many false rejections. If you're okay with just detecting elephants, you will have 100% true positives and almost no false rejections. That's kind of the collaterally of that. So, okay, so here you are. We have this fantastic system. Are we still the best system and the only system that's needed in the meat processing plant? And the fast answer is unfortunately no. Things like what X-rays can do, which is embedded metal, for example, where it does happen quite often when you have inoculation needles or something like that, we will never be able to find. So what we're seeing is a lot of our customers are doing a multimodal imaging or multi-hurdle approach, where they will have an X-ray, a PPO, and a metal detector maybe after packaging, just to make sure that any new introduced materials or materials that one technology can't detect is detected by something else. It's the same as when you go to a doctor and you get ultrasound for muscles and tears and X-rays for breaks. Same idea applies here. Okay. But let me dive maybe a little bit deeper into how these machines differ. First technology I mentioned before is people. And people, when there are several problems with how people look at foreign materials. First of all, they vary a lot from a person to person on their detection ability. Their age, their sex, their eyesight, their attention of the day, all make a huge impact on detection. And people get tired. So this graph shows you if someone is fully rested and just starts an inspection task to find defects, they will find 90% of the defects, no problem. But their attention drops within an hour, they will only find about 40% of the defects. And this has been studied in many different industries. So people, are very poor detectors. And the problem is, even when somebody thinks about, well, if one person is a bad detector, maybe if I have 20 of them, it will be a better detector. Actually, no, because now social pressures come in. So when you have 20 people on the line, they're more likely to abdicate their responsibility, think that the other 19 will find it, and they start chatting and not paying attention. So actually, there is a balance in how many people you want to have online. So people. And this is our primary method of detecting defects is people. This is what we have in the plant. Not great. So then we have, X-rays. And X-rays are great at metals, very dense plastics, very dense objects. And they actually now, with the new, well, not so new, dual energy X-rays, you can start finding density differences. So for example, lean point, or measuring how much fat, how much protein there is doable. It's not perfect science. They do have lookup charts, but at least you can guesstimate some aspects of chemistry. In standard vision, we do have a few problems. And that's really the low contrast aspect. So think about finding a needle on light uniform floor versus a needle on a carpet. It's the same issue. So if you have large chunks of product, let's say a ham, finding one piece of blue plastic on it is not a big deal. If you have a ground ham and a small piece of plastic, it's much more difficult to find. So that's true for vision systems. Although, you know, their new algorithms, new AI methodology has made these systems somewhat better. Hyperspectral imaging, as I mentioned, allows us to see chemistry, and kind of to what Maurice alluded to, because we see chemistry, foreign materials are just the tip of the iceberg of what we can find. So already our technology has shown that we can find things, and I know in Europe it's a little bit less of a problem, but in North America, especially in the States, when the chickens are this big, woody breast and spaghetti breasts are becoming an issue. So it's a strange aspect how the chicken grows. Their muscles atrophy a little bit and become very unpleasant in texture, very dry, don't absorb flavors very easily, and are just a bad product. So even when you grind them and stick them in sausages, the product is not as good. So we can find that, and we directly measure lean point, for example. So X-rays actually have to, because they see differences in density, they assume that fat is a certain density, protein is a certain density, and they kind of calculate it. We actually directly measure correlation between fat and our spectral information. So much, much cleaner. And we have started seeing other things. So we see patterns and trends in moisture and pH online at line speeds while we're finding foreign materials. So it's the same system, can do a lot of other measurements. So give you another idea. This would be a typical X-ray. There are actually bone fragments. I don't know if you can see them, but there are these faint lines. You can see bone fragments. And this is a typical cheap X-ray system. Fancier systems are dual energy, so they will have high energy and low energy X-rays, depending on the density differences of bones or cartilage. They can see slightly different things. If you combine the 2 pixels, it's as if you had 2 color glasses as opposed to black and white glasses, okay? But that's kind of the extent of X-ray technology right now. Most of the systems on the market right now are 2 energy. And here is a standard camera image. Again, nothing surprising. You see 3 colors, the red, green, and blue. And your eyes work almost the same as a camera, so, you know, it's something that we're all very used to. Several customers use what they call multispectral imaging, which would be select bands of color that are of interest. So for example, if you're sorting nuts and you want to find shell in a nut, you know exactly which spectral piece would be of interest, what would reflect more light. So you can tune your illumination, for example, to generate those colors, and therefore you can make machines that are much faster in sorting things out. So this would be a TOMRA system, for example, would be something like this, where they look at 10, 16 wavelengths. And then there is the PPO system, where we actually look at 600 wavelengths and have a continuous kind of information band for every piece of chemistry on there. So this has more information, but it also, we needed to build a system that allows us to process this information very quickly. And this is what we've been successful at here with Bluecon as well. So So I'm going to maybe run through a few examples. So this is a large pork producer, and you can see actually our system is slightly different. We're tumbling product so that we see both top and bottom of the surface of the product, so we see as much surface as possible. And I will ask our team here. So we can see we have essentially first imaging module here looks at the top of the product. The product tumbles, flips, and we see it following after that. We have a retractable rejection here if something was detected, and a retractable rejection here as well. But you can kind of see how product is presented quite in a very uniform layer. You can see kind of the volume and the speed of at which the product is moving. So this is an example of actually a customer doing a test between us, X-rays, and hyperspectral imaging, and kind of what materials were found with each technology. Why I like showing this, it's not data obtained in our laboratory, but it's actually a customer that's now paying customer did this test. So we still have issues with something like glass, which is super transparent for the near-infrared, in the near-infrared band. But as you can see, we have very few issues, whereas most other technologies have a lot. And I did mention this is probably my favorite slide. As we're learning more, as we're seeing more and more in-plant foreign materials, our detection rate is improving, and we're seeing some objects that are extremely small. So this is an example that we obtained from our pork producer. Essentially what you're seeing is each bar represents a week of findings in the plant. For example, one of our customers has ink tattoos on their pork, so we can see that we were finding ink. And in this case, they initially wanted us to reject ink because it's not really great in product, but after they found this plot, we're not rejecting ink anymore. So there is a bit of tunability allowed here. But you can see kind of white plastic is the yellow here, so quite a bit of belt. Cardboard is orange. So, we can kind of tell also what kind of products we're rejecting. Okay. And this is, we did get permission to show some Plucon data. This is the last weeks of operation, also showing, I would say this is a very, very clean plant because we're not seeing too many foreign materials each week. And you can see green plastic and blue plastic being kind of the largest components of what's being found right now. And these are also examples from Plucon, also shown with their permission, but things that we can find, clear plastics, yellow liner, things that would have been very difficult to spot in plant by a human. We also provide our customers with ability to kind of record each rejection. So after something is rejected into a bin, the plant staff can go and actually find the issue, and we're kind of giving them ability to track information over time. What was rejected, what was it, and it allows us to train over time, but also allows the customer to really do inspections of trends in their plant. And here are just a few issues that we found. So for example, this was a newly installed machine in the US, found a piece of orange plastic that would have been very difficult to find, something that was very unexpected. They didn't really know what material it was till we found it, and they were able to kind of look upstream to see what's going on. And this is how our system would have seen it. So belt, meat, and something that's not either one of those. You can see that orange plastic. And this is, again, kind of just, playing with the image. What would you have had to do if you were just a camera system? Again, we see we can really pinpoint an issue very thoroughly. And again, to me, is what's not surrounded by yellow, so what we haven't rejected. Normal meat just goes through, whether it's reflection or an ice crystal or hair or whatever, we can just tune it out and it goes through the system. And this is a poultry processor, also in the U.S. We found a lot of their liners are one color, it's blue. So a lot of liners from their bins, some metal. Wood is very prevalent in some of the plants that we work with because their pallets are all wood, tend not to be metal or plastic. But this particular customer told us that looking at ROI of replacing humans, less condemns, and kind of less time of product that they had to re-inspect, saved them about $1 million a year. So what does our system do? It not only saves money by eliminating people, but it really helps to retain customers, reduce chargebacks, and enable premium pricing. So we actually have a customer in the States who had product that was so contaminated that they had to render it and just take a loss. They were able to recover the product and actually make it an edible product to sell. So with that, I'm going to end our experience and pass the mic to Bart, who can talk a little bit about the Plucon install.
Yes, thank you very much. So Plucon Food Group, we are a producer of fresh and frozen poultry meat products. In the Netherlands, we also do some meal components and ready meals, but in the other countries, it's mainly poultry. That's fresh, frozen, for retail, industry, food service, so the whole variety. This is the oldest picture we have. It's from 1894. That's where we had the first proof of founding Plucon. The turnover each year is around 3.2 million. These are figures of 2024. We have around 9,500 people that we employ over all the companies. 33 locations in 6 countries, and we have 4 concepts of chickens. So that's more and more a thing that you have in the Netherlands. We have the slow grow bird. And you also see that happening in the industry market and also in retail markets in other countries. Figures are already a little bit old because we have 36 locations now in 7 countries. Denmark is the latest addition, but it was not in the slides yet. So we have multiple sites through the countries, and what we normally try to do is that each country can process a chicken from A to Z, and also you have the whole integration chain, so the hatcheries, but also further processing, slaughtering. So basically we can go from farm to fork on each country, and especially with the concepts, that's important that you have the whole chicken within one country processed and that you don't need to cross any borders. Over the years, we had a steady volume growth in broilers, and that's partially with natural growth, so the autonomous growth, and also by acquisitions, and that's growing and growing for Spain and Denmark as the latest additions. In the retail market, we have some big customers. In the Netherlands, our biggest customer is Albert Heijn. So the whole chicken, all the chicken products are coming from us, but also the smaller supermarkets like Plus, food service like Metro is also part of it. Lidl in Germany. So yeah, that's in all the countries we collaborate together with the big retailers, and we try to have a partnership with them so that you can grow. Also, if you're looking at these techniques, because it's quite an investment that you have to make. So we try to work with long-term collaborations also with the customers. In industry and food service, we work together also with the bigger parties. McDonald's, for example, is also very tough on foreign bodies nowadays. So they have the goal to reach 0% foreign bodies. So also in that market, you see a lot of push on these techniques. And they ask us, okay, what can we do to reduce the amount of foreign bodies? Let's look on in general. Now we go to the project of the PPO. We have one site in Ommel, in the south of the Netherlands. And they came up with a question, we need a solution to find foreign bodies, non-chicken related, on the incoming product stream. And that's basically what we do in the Netherlands. We have multiple slaughterhouses, and a part of those products are ending up in Ommel to be processed as hamburgers, schnitzels, farm products. And what you see, what's happening is in a slaughterhouse, if they know that it's not the final product, they care less about the product. And that's why you see where all the foreign bodies get introduced. So it's not their final product, so throw it away and let Ommel deal with it. And there you see the problem starting, basically. So what Ommel does is they produce foreign products. So what you basically do is you can process fillets, inners, leg meat into schnitzels or cordon bleu products, hamburgers. Also breaded, so with a crumb layer on the outside. And next to the plant, they also have a meat cutting plant where they harvest the fillets from the chickens. So it's basically our two plants in one. Looking at the production process they had at the start of the project, is they had an incoming stream of frozen raw materials coming from the sister plants, or Plucon plants. They store it for a certain time, and then when they have to produce those foreign products, they defrost them, and then they did a visual check on the product. So the defrosted product came over here, they tip it over, and it was transported to a table where people were visually inspecting the product on the foreign bodies. And we saw it is labor intensive because keeping focus on the product. And as Olga also mentioned, is that the accuracy of a person gets lower quite rapidly. But at the time it was what it was. And then the product went through preparation, mixing, and a risk of that mixing project is that, or mixing step is that if there is a piece of plastic, you pull it through a grinder, it's not one piece of plastic anymore, but it's 100 pieces. So especially on those forming processes, foreign bodies are challenging. And after the forming, you get the cooking process and the cooling, and then we store the products in a cold store. And after that, they go to the retail supermarkets. Looking at the products, we basically have 4 products which we process into burgers and schnitzels. That's leg meat, the thigh meat, the fillets, and the inners. So that's also the scope of the materials we run through the PPO machine nowadays. And looking at foreign bodies, we have quite a nice collection at all the plants. And I think they are familiar to meat processors.
Where do you find the most?
I think the liners, because we put all the product into crates, and all the crates have a liner.
Yeah.
And especially as soon as the point when you start to freeze the product with the liner on, then the hassle starts. But also gloves, hairnets, piece of cotton from the jackets. Those are the problem materials. And for Ommel, that's not really the case, but we see in a QSR plant, like where we produce McDonald's, that are more automated plants. And there you see that if a conveyor breaks down, nobody sees it anymore, and it ends up in the final destination. So it varies on the type of plant, type of product, and type of industry. I think we are already, before we did this, we always had the philosophy, If the foreign body cannot get there, you don't have the problem. So we try to do a lot, reduce the amount of liners and all those kind of actions we already did, but then still you have a certain percentage left. So this was, for us, the starting point. Also, transparent products, transparent liners, and the color of the liners, for us, it's also indicating which concept is there. So there was a certain value in having multiple colored liners in the process. So at the time, and it was already 2020, we start searching on what techniques are there available. And if you look at what's available, there are quite some solutions. At the time, Marel was starting developments on a new system. We had the PPO system. There was another American supplier, also some European systems. But mainly we saw basically 3 types of systems. There's the normal RGB cameras, the multispectral systems, and the hyperspectral systems. Each having its own price and performance level. We came to the conclusion that we needed a 2-sided inspection by either flipping the product or have a waterfall inspection so that you can look at both sides at the same time. We also did some testing at the time, and as said, the investment and performance are heavily depending on the type of camera technique. And what was difficult for us at the time is that you cannot make a hard comparison between the techniques, because it's the model in the machine and the training you do at the machine which finally determines how accurate it is. And at the time of testing, you get a general model. So it is difficult if you buy an X-ray or you buy a metal detector, then you can say, okay, I take a small piece and feed it through 3 types of machine and let's see what's the best machine. But in this case, that's, you cannot make a hard comparison on that part. And looking at Plukon Ommel, where we have a lot of sources where material are coming from, we decided at the time, okay, let's go for the best system possible from a technical point of view. So then we have the best chance finding the most materials. So for a slaughterhouse, for example, we also working on foreign bodies, but then we sometimes work with a normal camera, because then you're in control of your own foreign bodies and then you can steer it a little bit. But over here, it's such a wider scope of materials, you need a better performing system, so to say. So we decided to go for the PPO system, and then we started talking and testing. So we did quite some back and forth with sample sets of material, testing on remote. So they were performing the tests in Canada on the testing system. We showed, like on the left, what our problems are, and we came to the conclusion together that the problem we had with the liners is more a European problem than a North American problem, and that the standard detection model was not trained on those liners specifically. So at the time we made an agreement that we bought the machine with an additional model to find liners. So that was a separate action we did to get to the result we would like to have. So that was quite some time went on before we officially signed the contract, due to some research, other priorities, and also we had quite to do some talking to have the investment there. But mid-2023 we started the project. We had regular calls during the project, also a little bit on adaptation to the European market, and we made some small changes to the machine. And Hellebrekers performed the change from Allen Bradley to Siemens, to a more available technique over here. When the system was ready, we put it into the plant and we did a data collection phase. So that's where we trained the model. We took the 4 products we had, we ran it through the machine, a lot of kilos to train the model. And after that, they built the model and we did a successful commissioning in February 2025. And yeah, in my point of view, it took a little bit longer than needed, but we had some other priorities, and that's also always the problem with production. It has to go on. For us, the PPO also meant a new way of working. So what I described, where we, in the past, we received incoming frozen raw materials and we put it into cold store. We now work in a different way. We collect all the incoming materials fresh from the sister plants. We bring it to Ommel, and then we build a small inspection lane with a hyperspectral imaging from PPO and an X-ray machine. And then we do inline plate freezing in naked blocks, and then we put naked blocks into a cold store. So we reduce the need of liners on foreign bodies, or liners on products, and reduce the amount of foreign bodies. And we know that all the products that is in the cold store is checked and is okay. And that solves a lot of issues. And for us, we now also have inline freezing completely automated. So there's also an ROI project on that, reducing the amount of people needed. So now we start the defrost process with clean product, and then we do preparation and mixing without the need of any people looking at the product. So here I have a picture of the layout, and it was during building, but we start with a product singulator. And what's important to know, like for vision products, it's if the camera cannot see it, it cannot detect it. With an X-ray, you can put a little bit on top of each other. But here, there's the need for a good singulation. So we build a vacuum machine that singulates the product. So then we get 3 lanes of product out, single product. And then we feed it into the PPO machine, where we have the 2-sided inspection. Then on the side, we have a small reject belt. So if there are any rejects from PPO, they end up here. And someone from the QA department checks what is there, and we also register it on the batch, so we know how each sister plant is performing. And from there we go into the X-ray machine, where we do the check on basically on metals, but also on bone, because in chicken during the filleting process you introduce bone. And what's nice as a catch we have basically is that the PPO machine also sees cartilage. So where X-rays are struggling with cartilage, the vision machine is seeing it. So for us, that's a nice to have in the project. Experience so far, like on the specific performance, I think Jamie is going to have insights on that. So I will leave that to him. Looking at the system, we're happy with it. It's performing well. Some small issues, but since commissioning, it's running stable. The washdown design is good. You can see it's a thought-through design. We don't have any problems with water in the system. And there are a lot of computers and there's a lot of technique in the system, but until now, no problem. Yeah, product presentation is important. It's key for the performance of the system. If you throw a pile of product in, it is not accurate, and that has nothing to do with the system. And nowadays we run around 250 pieces a minute, and it can be an inner or a fillet, so it's not a kilogram, but it's pieces. For us, that's enough, and that's more than enough to take the incoming stream every day. The one thing that we don't know if that our complaints are dropping at the customers, because the product is still in the cold store. We didn't process it yet, but so we don't know if the stream of complaints is going down. We also we didn't have a lot of complaints, so it's difficult. But we see in the results that we are finding product, and also the people on the line, they were finding product. We only don't know if are they performing as good, or is the system better or not. We simply don't know. So that's it from my side. Thank you for your attention, and I don't know if there are any questions. But
more foreign objects now than that you did with the human inspection?
I think we find more. The problem is all the sister plants, they also know that we have the inspection line now. So it's the human factor in this is the big problem. But we see, especially, I think we also have some examples like some transparent foils and also some yellow transparent films. The system finds it, and I think a person would never find it. Okay, thank you very much.
Okay, so I think right now we're about to go live to the Plucon plant. So one of our customer success director, Jamie Polko, is, I think, there. Jamie, is that you? I can't tell.
Hi. Can you hear me okay?
Yes, we can hear you. All right. So,
Okay. Well, we're here in the plant, and so this is the system, obviously. Stop me at any point if you want to look at anything a little bit more. Up top, we've got all the hyperspectral imaging computers, etc., that are up there, all the electronics and everything that are running the system. And I think earlier in the presentation, we talked about the Z or Z configuration, how product kind of flows over to the first detector module here, gets inspected, gets flipped over, runs down the second conveyor, goes through the inspection line of the second detector module, gets flipped back over onto its far side, and then there's a rejection mechanism. We'll do a demonstration of a reject in just a few moments. So hyperspectral lamps, system does a calibration on its own one time in the day when you push the green start button at the beginning of the day. And the cameras are housed inside of here. You can clean this whole area down, sanitize it every night as you wish. Yeah, so that's the machine. If we were to pull open one of these doors, the system would completely shut off. I'm not going to do that because we're in production right now. So I can do a demonstration, or if there's any questions before I do a demonstration of what a rejection looks like, I'll just pause here for a moment.
do you have any questions? Okay, so Jamie, can you actually please show us a rejection, what it would look like?
Yeah, for sure.
Okay.
So I'm going to take a glove because, again, I don't want to throw anything too small into the system right now. I'm going to put this through, and then the camera guy is going to follow it through the machine, and you'll see the rejection take place in just a moment. So I've got my blue glove going into the system. You see it flow through past detector module 1, onto detector module 2, onto the final conveyor, and then there's a reject that occurs. So because it's so light, it didn't actually get rejected because it's also nice and dry. It's not part of the product, and it flipped and didn't go where I expected it to. So
Okay,
that's sorry.
Can you try it again and just maybe show the rejection end a little bit?
Sure.
Yeah.
Here. I'll get it a little bit more chickeny too. So camera guy, if you just want to stay at the reject mechanism, then I'll put this through. So product there.
Oh,
It got caught. This is
and
part
we lost
of
him.
a live demo, right? This is real life. I can show an example of something that the machine found earlier today, a green piece of plastic. It's over here on our table if we want to come over and take a look at it. It's right here, nice and easy to see. So this was on a piece of chicken and was rejected earlier today. So earlier in the presentation, I think you saw Olga pointed out PPO insights. Plucon has done a great job and put a terminal out here on the plant floor so the operator can see the detections that occur by the machine. We can go and actually take a look at one if we wish to. You can see the glove underneath the piece of chicken and a highlighted location of it. That's part of the feature of PPO Insights, that it's going to show you the detection and what was detected each time.
So as far as capacity, can you tell anything about the width of the belts and the transport speed they are moving?
Sure. And sorry, we in Canada, we're kind of mixed units, so I'm going to be talking in feet. But we're about 30, we're 30 inches wide, so about a meter. And then the speed is 80 feet to 100 feet per minute. So we can look at around relatively uniform thickness of about 5 centimeters. We can see about 60,000 pounds, so that's what, 20-something thousand kilos a minute. No. An hour, sorry. Yeah. Well. Okay, I was so busy converting from one to the other that...
So earlier, Plucon said that they had a period of data collection, I understand. How long did this period take? How long do you need to train your model?
Yeah, so for something that we would have seen already, our systems start rejecting first a couple of days after install. And then we fine-tune for about a week on true positives, and several weeks, about 3, on rejections. Okay. Oh, sorry. So it's, I would say, about a month, but the system is operational, and depending on how we agree with the customer, we can be rejecting or not rejecting at the when we're training. For something super new, where the liners were quite unusual for us, slightly different chemistry, very different thicknesses and colors. This was a process, and also doing it, across the ocean. Understanding each other took a little bit longer, but I think towards the end it was about 3 months of solid work.
Do you train the model by a variation of product and piece you don't you want to select?
So right now, if we want to kind of identify families of the foreign materials, yes, we kind of have to see most of the foreign materials going through a plant. However, we can reject things that we've never seen before if they look unusual. What is very important, and why we take a long time to do the false positive training, is learn the variability of the product. What we're seeing is, if you just look at the product for a day, if it's a little bit cooler, if it's a slightly different plant, if the chickens were slightly more mature, all of that will affect the product. So we have to have kind of as much variability of product seen by our system to really fine-tune the rejection and the passing of the false positives. So again, it depends also how critical the plant needs to be. So in some instances, like a little bit of cardboard going through is not a big deal because it will be ground further down. Obviously, nobody wants to find blue plastics in their sausages, right? So there is a tuning also. The plant gets to learn about us. It's not just a single kind of one-directional process.
Have you ever tried to implement this in the slaughter lines or bone-in products, hanging?
So we have in chicken slaughter plants, but quite a bit further away from the slaughter. In large animals, we actually have a project looking at offal really close to the slaughter. The problem is with presentation. The depth of an entire half a pig, for example, is so large that we can't focus. This is really meant to be looking at something that's about 20 centimeters tall at the most, with not too much variability in thickness. Very similar to X-rays. You know, you kind of have to present the product in a relatively uniform way. Do I think that will go that way? Yes. But it also depends on the value proposition for the customers. Where our products are heading right now is, you know, when you're presenting a new technology, you actually have to do a turnkey solution. So it detects, it rejects, it's washed down. Nobody is going to spend any engineering time on a new technology in their plant. They just want it to work. Now that we have experience and people trust our technology that it does its job, we're actually shrinking our systems. So some of the modules that you saw kind of attached inside of the system, we think we can start removing them away. We've learned also to be much less dependent on our own belt. And for example, the distance between the computers and the camera has changed. Now we can have much larger distances, which allows us now to put several modules along the entire length of a line, for example. And I think for animals, that will be easier to inspect. Oh, Jamie, sorry, so...
I'm back?
You are back.
Excellent, good.
So do you want to make
Should
the
we
glove?
try glove one more time?
Yes, please, because I didn't even see the rejection pull back, but I think the audience did. So let's make the glove wet and heavy.
Or, Jamie,
Yep.
geez. Jamie, can we try the target maybe instead of the glove?
But glove is so much more... I know.
it's cool, but the glove is just... Oh, we're putting chicken in the glove?
Oh, there.
Here, I will put the glove with chicken inside. Okay, and then we should see the reject mechanism now. Pull back and reject. Comes out on the reject conveyor.
And there.
And into the bin.
Okay.
If we refresh PPO Insights, we'll be able to see plant Wi-Fi is not always the best. This one's pretty good. So you can see on the screen the blue glove that was detected with the detections highlighted.
Everybody see that
on
okay?
The second detector module, and then same thing on the first detector module. You can see the same thing. So the blue glove, and because we have both cameras, we have both a visual camera and a hyperspectral camera inside the system, we get the luxury of both images. So we get one to see what you and I would see, and then we also get to see what the spectrometer saw too. Did everybody see that?
Do you have any questions for Jamie? And Jamie,
Yes.
as you were standing there, we see that the rejection bin is pretty full, or there are some
Yes.
pieces there. Did you find anything interesting on them, or is it just
So
false rejections?
In the reject bin here was from our failed attempts at getting the glove through the first time.
Oh, okay, gotcha. Okay,
Yeah. So no foreign bodies or foreign materials in the bin. There's been a couple today, the one being the green piece of plastic I showed earlier, and then the QA team has taken the other ones away.
okay. Thank you. You had a question?
Yeah, sometimes there's in the meat there's an abscess. You know,
Yeah.
can the system find that as well?
If it's close to the surface, yes, and that's actually one of our projects in Australia. The one with offal is exactly that, looking at disease states in offal. If it's very deeply buried, if we can't see some structural or chemical signature, we won't be able to detect it. But we have seen abscesses, we have seen feathers, we have seen wounds on animals, especially on pork.
Yeah, I talk about pork, yeah.
Is the detection of the chemical part, like pH, also based on vision, on the same?
Yes, so pH, again, it's when you're doing spectroscopy, it's really a correlation of shape of the spectra to amounts of something. We are picking up a lot of moisture.
I think we're done.
Oh, oh, sorry, Jamie. Thank you.
Yep.
Okay, hold on. Okay, yeah, can you just leave this shot for now? And if you see anything reject, can we look at it? And well, I'll just answer some of the questions, okay?
Of course, yep.
Thank you. It looks really cool. Thank you for being dressed up and doing this, team. Okay, so pH, we do see essentially the chemical, obviously acidity, but I think we're also seeing a little bit correlation with water holding capacity there.
So now this is, let's say, chicken, and you also talked about pork. How about if I have a line with more or less mixed products? So we make a lot of several ground products. So we have beef, we have pork, we have chicken. So we have all kinds of different base products which we have to find are not wanted elements of.
A great question. So actually, because by now we have multiple deployments, we do have a couple of customers who have mixed backgrounds. And again, our models they do differentiate between types of meat. However, we have now a large library of what's happening. Now, typically in a mixed plant, we do kind of want to watch typical mixtures. So you probably do have a proportion that you prefer more often. We would want to do a inspection of that for several weeks probably running, just to make sure that we understand the background. But there aren't, protein is different than everything else. So our models transfer relatively well from protein to protein. And there's fine tuning that needs to happen though.
So can you tell, I don't know if it's been running, if you already have the numbers, do you have any idea about the false positives and false negatives in this system?
So we do a very thorough testing. Contractually, we always promise about less than 0.5% by weight of product going through the machine. And most of our operations in chicken are less than 0.2% of product by weight. This one, Jamie, you might actually know. Can you hear us?
Yeah, I can
hear you. Do you know what's the false rejection rate at Plucon after?
Around 0.2%. I think it was 0.18.
There you are. And again, it's by weight, because if you're looking by pixels or by detections, it doesn't make sense. So it's all about weight of the product.
There's some discussion about what is false positive. Is it waste or is it...
Oh, it really depends on the customer. So we have customers that will actually, regardless of how much we reject, it's a high-end product, they throw it all out. I think we have one customer like that. Most reinspect in a bin and then put the clean product in. And there's one or two that actually does the reinspection and dumps the entire bin at the front of our machine and runs it again. So it depends on the flow. As you can see here, we're quite flexible. So this bin is put in, but it really depends on the customer. So, Jamie, you visit the most customers. Do you want to say, like, what are the biggest questions that our customers ask?
So, some of the biggest questions that our customers ask are around the false rejections. How many of them? As you can see, during this entire time, there hasn't been one. One of the other things is it reliable? Does my maintenance team have to take care of this machine? Do I have to call them all the time? I'll quote one of the plant managers at one of our facilities in the United States, who says, "We never touch your machine." He said, "I can't say that about any other piece of equipment in our plant." I think if you ask the plant manager here or the maintenance team here, they'd reiterate that exact same thing. Startup process is extremely easy. There is a little bit of work to do in the morning. You have about 5 or 6 minutes of startup procedure to follow. But other than that, I think we've done a pretty good job of trying to make it as simple as possible. And I haven't been to this plant in a little while, and the operator said, "This machine is so easy to work with. I don't really have to do much." He said, "I can't say that about the X-ray even in the same room." So those are some of the common questions I think we get, really around maintenance and false rejections. And does it find everything? That's one of the other things. So the machine is very good at finding things that are not normal. And as you can see, there hasn't been any false rejections here today, because all of this product is normal. It's a very clean product as well here at this facility. So does it find everything? It does a pretty good job of finding most things.
And Jamie, can you also point out to things that we replace on the machine and kind of the schedule?
Oh, yeah, for sure. Sorry. So during a regular maintenance visit, which happens every 6 months, we actually replace all 4 hyperspectral lamps at each detector module. Our highly trained technicians also open up the detector module, do some inspections on the optics that are inside, do some replacements of some components that have a 6-month life. And Hellebrekers is our partner here in Europe, and they are trained to do this work for us. They've done the service on this machine. We're going to be doing it again in August. So we will they'll be leading that maintenance and that service. So having local service here in Europe was really, really important to us, because there's no way we could support it from North America alone. We work very closely with the Hellebrekers team on training of common things we find where we have a lot more machines, so that they're armed in case anything does happen here with this machine or any other machine that we install.
Thank you. And how about, what are the most important things that the customer needs to do with the machine to make sure that it operates well?
So making sure that the optics, we're an optics-based technology, so making sure the optics are beautiful and clean every single day. So where the scan line happens, where all that bright light everybody can see, there's a window that's on the bottom of the detector module. Making sure that that's perfect and pristinely clean every single morning, that's going to give you the best chance at finding any foreign materials that are in the product stream. So that's the part of the startup procedure I was speaking about. Making sure the optics are clean, doing a calibration. And what is calibration? That's this arm here. I don't know if you guys can see it. And there's a piece of special plastic on the bottom of it. It swings down. level sets for the day, brings it back up, so it's all integrated, and it's a single button push for your operator. They clear the faults, they do the work they have to do on the inside, wiping down the lenses, etc. Push one button, the machine will automatically calibrate as necessary before product flow, and warm up all the lamps, get everything ready for operation, and then the stacked light, which you can't see, but it's on the far side of here, and you also get a lot of visual cues on the HMI saying that are bright green, saying that scanning is active, and the HMI is accessible from the other side of the machine or this side of the machine. It's totally movable, so it's easy for the operator to use.
Thank you. And by the way, all the calibrations are stored in the cloud, and we can actually see trends. For example, lamps deteriorate over time, so we know when a failure is maybe imminent or something like this. We can proactively fix it. So any kind of departures from normal, we detect quite quickly and talk with our customers about those.
And to just add on top of that, because the machine is connected, we have access to remotely support the machine, and so does the Hellebrekers team as well. Not only calibrations, but other things our teams are monitoring to see if there's anything going on with the machine. If there is something that is looking not right to us, we just had this at a machine in the United States just the other day, where we saw something that the customer didn't even realize was happening. We called them to say, hey, can you send a maintenance guy down? We think this needs to be looked at in this, because it's not reacting the way we expect it to. Kind of being a bit more proactive than reactive on the maintenance side and on the operation side as well. So we do that with this system here at Pluton via the Hellebrekers team, but then also all of our customers globally.
Thank you. You had a question?
Yeah, about the false negatives. Are you collaborating with the customers to trace down batches where the customer, for example, found the false negatives and to improve the model?
Yes.
Check why you missed it?
Yes, actually we had a situation like this in a chicken processing plant where typical chicken being processed were hens, and all of a sudden we started seeing rooster breasts, which were slightly different, and we were starting to get significantly more false positives that week. We called them, figured out that it's a new product that they're looking at. I think it took us about 24 hours to change the model sufficiently to stop the false rejections.
Yeah, but it's the rejections, but I mean the false negatives.
Oh, false negatives. So we do have a couple of customers that still have inspectors behind us. And yes, one of them has found 0 foreign materials in 2 years after the PPO. And they actually had a second identical line without a PPO, and they did find foreign materials on that one. And then, we had one customer that came to us with a zip tie from something. And it was their customer found it. What we were able to show is that A, the PPO would have found it, and B, that no zip tie of that type exists in the plant of our customer. Okay.
Jamie? Shit, sorry.
Yes.
Can you do me a favor and talk a little bit about, there is an occasional time when the system misses something. I'm going to stand back here. And what you do with them when that happens to see whether the system could have detected it or not. Do you want to just talk through that process a little bit?
Yeah, for sure. So if you find a piece of foreign material downstream, then what we do is we work directly with our customer to try and understand, is this embedded in the product? Was it not presented to the machine in a way that it had to be a chance to actually see it? Or do we need to do some model optimizations for this in order to be able to detect it the next time? So what we do is we use a foreign material that we know we're going to catch. So a glove or something else, we tend to send validation cards with our system. So what we do is we put that foreign body on top of product through the machine, decide something that we know it's going to detect. What that does is that gives our model team the ability to download that information, do an analysis of the foreign objects, the information around it, and make a determination on how do we go about optimizing the model so that it could find that thing next time, or we see that yes, it actually does detect it, and it shows the detections of that foreign object. So that's how we can verify, is this a false negative, or was it just not presented correctly?
And that happens so rarely that's why none of us thought of it at first.
And actually, what are the limitations? This is a kind of natural question. So very shiny objects reflect all light, so that's very difficult to detect. Very dark objects are very difficult to tell apart from shadows. So that's where a kind of shape and size and blurriness is used on top of chemical information, because we're also a vision system. We have normal cameras in there. We kind of combine the two images together to get better certainty. And then things like at Plucon, really the thin liners that are transparent. If they're transparent for most wavelengths, and they're super thin, so there is very little interaction between photons and the material, it becomes difficult. The one example we were talking about, the glove that we train on wet things, initially that was also an issue, right? Foreign materials in stream of material are different chemically because they have grease, they have water, whatever on top. We have to think of the training procedure to represent the real plant as opposed to experimental laboratory. Sure.
Does the machine work with programs? So now we running small parts, but if you run bigger parts, do you have to change?
So again, the machine kind of has about 20 centimeter field of view and about 30 centimeters kind of space for things to go through. Yes, if we know the program, right now we're starting to learn to recognize standard products. We do have a couple of customers that we can kind of predict what's going through, and then yes, we kind of change which models we use. So we have a portfolio of models that we deploy on a given machine.
Okay, and the maintenance, I heard half a year you have to change the glass and...
Jamie, maybe you can give a little bit more info, but the most often what we change is the lights. Everything else is less. But Jamie, you know all the details.
Yeah, so let me just make sure I heard it right, because as I'm putting my hands up to my ears because it's very difficult to hear you guys sometimes. So what I heard was we have to change, what are the maintenance items every 6 months? Did I hear that right?
Yeah, like how often do we have to maintain the machine?
Yeah, okay, right. So every 6 months we have to replace the hyperspectral lamps. The reason we have to do that is because we need all of the wavelengths for the spectrometer to work effectively. And we don't notice it, but the spectrometer does in the amount of intensity for each individual wavelength changes over time. The lifespan of a bulb for our purposes is approximately 8 to 9 months. We don't want to go to failure. We want to be proactive, and we want to make sure that we get those lamps changed out beforehand. Now the lamps are not field serviceable, so when we sell a machine, we also sell a spare lamp or two, depending on the customer's risk tolerance. But typically lamps can go out. That is one thing that is a maintenance item. The majority of everything else is just a conveyor. Not to dumb it down too much, but that's really what we're looking at, right? The real magic is inside that box and inside all of the computers that are up top, and then the communication between them, obviously. But the rest of the machine is run by VFDs. We use Danfoss VFDs, we're using Siemens PLCs here, all the common, normal things that you would have in your plant and common breakers, etc. We're using ABB safety circuits and relays. So pretty much everything is replaced as necessary, with the exception of the lamps themselves. That's a maintenance item that has to be done, along with some of the optical components inside the detector module itself. Those have to be also replaced every 6 months as well. But everything else is run to failure pretty much.
Okay, and now the big question, what is the cost of that?
So this machine right now would sell for about $900,000 US.
No, I now meant the maintenance.
Oh, Jamie, maintenance?
Yes?
What's the maintenance cost?
Okay. So for
depends.
the hardware, the components, the pieces, you're looking at every 6 months about $4,000 US. So $8,000 US per year for those hard maintenance items. There's also a maintenance agreement that gives you that PPO insights access, gives you a bunch of other things as well, that adds up a bit more than that. But the hard cost is about $8,000 per year for the maintenance items, and then the maintenance agreement, which gives you the software and the other things, is closer to. Heather, you'd have to correct me. Yeah, you have the most accurate pricing for that right now, I think.
Just for the people online. So in the US, we have a slightly different program than we do here, but the range is between about 55,000 and about 110,000, depending on the system you have and where you're located in the world. So I would tell you in Europe, just shoot an arrow right in the middle and you're probably close. Yeah. And there is it depends, like Ola said earlier.
If you're running multiple proteins, and other things play factors in that too.
And that would include us coming 2 times a year to replace your lights and do all the other checks on the system to make sure it works properly. I smell food. Did you guys, did you get all of your questions answered? We want to make sure you did. Okay.
Any other questions?
Okay, Jamie, thank you. Thank you to all the other folks in the plant who were disrupted today.
Jamie, thank you. Thank you so much.
No problem. Thanks all.
And thank you, our photographer, whom we haven't seen, but he did an excellent job keeping you in the picture.
Wonderful. All right, well, thanks, everybody.
Okay, take care. Stay warm. Bye.
Will do.
Okay, thank you all. And thank you for great questions.
And the webinar people too.
Oh, and thank you, webinar people. Hopefully some of our Canadian friends are there as well, so thank you. All right.